Lecture 5. Nomenclature. Objectives. Learn two broad classes of binary compounds. Learn to name binary compounds of a metal and a nonmetal. Learn to name binary compounds containing only nonmetals. Review the names of type 1, type 2, and type 3 binary compounds. Learn the names of common polyatomic ions and how to use them in naming compounds. Learn how the union. Composition determines the acid's name. Learn the names of common acids. Learn to write the formula of a compound given its name. Why nomenclature matters. Chemical nomenclature is the language of chemistry. A correct name tells you what elements are present, their relative amounts, whether the compound is ionic, molecular, or acidic. In chemistry, a name is never arbitrary. It is a code that contains chemical information. 1. Two broad classes of binary compounds. A binary compound contains two different elements. Class 1, ionic binary compounds. Metal plus nonmetal. Involve electron transfer. Form ions. Example, NaCl, NaCl. Class 2, molecular, covalent, binary compounds. Nonmetal plus nonmetal. Involve electron sharing. Discrete molecules. Example, CO2, N2O4. 2. Naming binary compounds, metal plus nonmetal, ionic. General rules. Name the metal first. Name the nonmetal second. Change the nonmetal ending to -ide. Do not use prefixes. Example, NaCl sodium chloride. Chow calcium oxide. 3. Type 1, Type 2, and Type 3 binary compounds. Type 1, fixed charge metals. Metals with only one common charge. Group 1, plus 1, Na, K. Group 2, plus 2, Ca superscript 2, Mg superscript 2. Al superscript 3, Zn superscript 2, Ag. Example, MgBr2 magnesium bromide. Type 2, variable charge metals.
Okay, let's stop into here. The first group is the type 1 that is made by a cation and an ion. In other words, a metal and a nonmetal. Remember that metals make cations and nonmetals make the anion that is negative charged. Here we have metals from the group 1, 2, from the other groups, except the transition metals, for example, lead and tin, that are from the representative metals, but they have more than one oxidation number. Then, in the group 1, we are going to have only, or type 1, we have only metals that have only one oxidation number. So they make only one type of cation. This is very easy. You name the cation and then the anion. For example, sodium chloride, magnesium hydroxide. But then we have the type 2 where you have more than one charge in the metals. Let's see what happened in this case.
Type 2, variable charge metals. Transition metals that can form more than one ion. Rule. Indicate the metal's charge using Roman numerals. Example, FeCl2 iron, 2 chloride. FeCl3 iron, 3 chloride. Roman numerals describe the charge, not the number of atoms. Type 3, binary.
Okay, let's stop here into type 2. Type 2 correspond to the metals that have more than one oxidation number or charge. They make two types of cation. For example, iron 2 is iron. Let me write here. Iron 2 plus. And iron 3 is iron plus 3. As the substances, well, you know, chloride is -1, chloride is -1. Then in this case, what we do, the 2 here goes down, and then the formula is FeCl2. And same thing here. Then it will be iron and 3 chlorides. But in order to distinguish this iron from this iron, we write into Roman numerals, into parentheses with Roman numbers, sorry, the oxidation number. If the charge here is +2, then you write a 2 in Roman numeral. If the charge here is +3, then you write the number 3 in Roman numeral into parentheses after the name of the cation. This is for the type 2. Type 2. Let's continue with the type 3. Let's see what happens with the type 3. And then
Type 3, binary compounds with polyatomic ions. It contains a polyatomic ion, a charged group of atoms. Example, NaNO3 sodium nitrate, CaCO3 calcium carbonate. For naming binary compounds of nonmetals, covalent. Rules for molecular compounds. Use Greek prefixes to indicate the number of atoms. First element keeps its name. Second element ends in -ide. Drop final vowel of prefix if next word starts with a vowel. Number. Prefix. 1. Mono. 2. Di. 3. Tri. 4. Tetra. 5. Penta. Examples. CO carbon monoxide, CO2 carbon dioxide, N2O4 dinitrogen tetroxide. Prefixes are never used for ionic compounds. 5 common polyatomic ions must memorize. Formula. Name. NH4. Ammonium. NO3. Nitrate. NO2. Nitrite. SO4 superscript 2. Sulfate. SO3 superscript 2. Sulfite. CO3 superscript 2. Carbonate. Phosphate. OH. Hydroxide. 8 has more oxygen than 8. More examples of polyatomic ions. 6. Naming compounds with polyatomic ions. Name the cation. Name the polyatomic ion unchanged. Examples. Na2SO4 sodium sulfate. FeNO3 3 iron 3 nitrate. 7. Acids. How composition determines the name. Acids are compounds that produce H in water. 2 main types of acids. A binary acids, no oxygen. Formula HX-AQ. Naming rule. Hydro plus nonmetal root plus IC acid. Examples. HCl hydrochloric acid, H2S hydrosulfuric acid. Deoxyacids contain oxygen based on polyatomic ions. Anion. Acid name. 8. IC acid. Ite. Us acid. Examples. NO3 nitric acid, HNO3. NO2 nitrous acid, HNO2. SO4 superscript 2 sulfuric acid, H2SO4. SO3 superscript 2 sulfurous acid, H2SO3. No hydro prefix for oxyacids. 8. Writing chemical formulas from names. Step-by-step strategy. Identify ions and charges. Balance the total charge to 0. Use subscripts, never change ion charges. Example. Calcium nitrate Ca superscript 2 and NO3 Ca, NO3, 2. Example. Iron 3, oxide Fe superscript 3 NO superscript 2 Fe2O3. 9. Common student pitfalls. Using prefixes for ionic compounds, forgetting Roman numerals for type 2 metals, mixing 8/ide acid names. Writing incorrect subscripts. Big picture summary. Nomenclature connects names, left-right arrow formulas, left-right arrow composition. Ionic versus covalent naming follows different rules. Polyatomic ions and acids follow predictable patterns. Mastery of nomenclature is essential for reactions, stoichiometry, lab work, communication in chemistry. One sentence takeaway. If you can name a compound and write its formula correctly, you understand how atoms combine, and that is the heart of chemistry. Tricky nomenclature questions, Lecture 5. 1. Ionic versus molecular, concept trap. Which compound must be named using Roman numerals? CaCl2b COC.
Theory.
Nice. White heavy checkmark, correct answer, C.
Okay, as you can see, which compound must be named using Roman numerals? Well, in order to use Roman numerals, you are supposed to watch out the first element. Well, in this case, carbon is a non-metal, then we don't have to take into account this element. Oh, calcium. Calcium belongs to group 2A, then it belongs to the group number 1, where you don't need to use Roman numerals. What about sodium? Same situation as before with calcium. If sodium belongs to group 1 and nothing, it has only one oxidation number +1. Oh, but iron belongs to the transition metal, and it can work with iron 2 or iron 3. So in this case, this is the element or the compound where you have to use Roman numerals to name the compound because it's a type 2 metal. Okay? Let's go to the following one. Prefix misuse trap. Which name is correct? Carbon monoxide okay, carbon monoxide. That's correct. Dinitrogen pentoxide. This is correct. Sodium dichloride. Sorry, no number 2. No number 2 here. Sodium chloride. Let's see what's going on here. Sodium is a metal. Then when you have a metal and a non-metal, you no prefixes. No prefixes. When you have two non-metals. Sorry, when you have a metal with a non-metal. This is ionic. Then you don't use prefixes with ionic compounds. Sulfur dioxide, trioxide, sorry. Yeah, a non-metal and a non-metal. Then the only case where you don't have to use prefixes is with sodium chloride because it's a metal and a non-metal. In this case, you have ionic compounds and you don't have to use prefixes. Okay, let's go to question number 3. Roman numeral meaning. Number of chloride ions, number of iron ions, oxidation state of iron, subscript of iron in the formula. Number of chloride ions? No. Number of iron atoms? No. Oxidation state of iron? Yes, because in this case is iron 3+. Subscript of iron in the formula? No, 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 no. So, the correct answer is C. Why? Because Roman numerals indicate the ionic charge, not atom count. Okay, let's go now from formula to name challenge. What is the correct name for this compound? Let's see. Copper oxide. Copper oxide. No. Copper 1 oxide. Yes, in this case, you have 2 copper 1 and an oxide that is -2. 2 times plus 1, 2 times plus 1 plus -2, it will give you 0. And the compound is neutral. Then, what is the correct name for copper this? Well, in this case, you have copper +1 and -2. This is the guy, because in this case, if it were copper 2, then it will be 2 times 2 plus, it will be +4. And dicopper, no. It's a metal at the beginning, then you cannot use prefixes. Okay? Let's see what is the answer they give you here for this exercise. For this exercise, they say copper monoxide, no prefixes, because it's a metal with a non-metal. Let's go to the polyatomic ion logic. Which compound contains nitride? Then you know that nitride is NO3. No, and this is nitrate, sorry. This is nitrate. And nitrite is NO2 negative 1. This is nitrite. Then, which compound contains the nitrite ion? This? No. This? No. This? No. Oh, this? Yes. The answer is B. Okay, let's continue. Acid naming trap. Well, hydrochloric acid. Every time you observe this name, hydrochloric means that you are in presence of chlorine. And of course, contains the hydrogen to make the acid. Then this is the correct. Which compound is named hydrochloric acid? Well, it could be this and could be this. Oh, but this is a gas and this is in aqueous solution and the acid is in aqueous solution. Then the right answer is this, C. Let's continue. 7. Oxyacid pattern recognition. What is the name of this compound? What is the name of this compound? Let's see. Let me put the question here. Okay, what is the name of this compound? First of all, you go to the anion. The anion is SO3. That is sulfite for the salt. Sulfite for the salt. When the ending is ite for acid, it changed into sulfurose. Then the correct answer is B. Sulfurose. Let's continue. Writing the formulas from the names. Okay, let's see. Iron 3. We have to find iron 3. You know that PO4 anion works with negative 3. What will be the charge here in order to get a neutral for a compound? Oh, of course, positive 3, because positive 3 and negative 3 cancel up, and you get a neutral compound. Then which one is the formula? Which one is the formula in this case? Well, you're not going to put a 3 here and a 3 here because they cancel up. So it's just FePO4. The answer is A. Let's go to the following one. Okay, here you have, why does calcium nitrate have this formula? Because calcium has 2 atoms. No. Nitrate has nitrogen atoms. Yes, and what? 2 nitrates valence calcium plus 2. Yes, that's right. This is the answer. And then prefix, no prefixes because we begin here with a cation, and with cations at the beginning, you don't use prefixes. The correct answer is C. Why? Because charge valence determine subscripts. Okay, let's continue. What about let me put this here down. Molecular compound, naming. Which formula corresponds to dinitrogen tetroxide? Then I know that we have nitrogen and we have oxygen. Di means two, and tetra means four. And this is the compound. The compound is C. Then, if you don't understand, you stop the video and go back and you watch it again and again until you understand all these concepts. Which compound is type 1? Well, type 1, remember that is from the group 1 and group 2 of the periodic table that are metals. So, iron is transition, copper is transition, magnesium is, oh, sorry, I didn't read the question very well. Type 1 ionic, type 1 ionic, I don't know because it's transition, copper no because it's transition, and tin can work with +2 and +4. So the answer is B, that is magnesium, that only works with one type of charge. Let's see, let's continue. Here we have another question. Acid versus salt confusion. Which compound is not an acid? Well, you can see here that you have hydrogen at the beginning, hydrogen at the beginning, and hydrogen at the beginning. Of course, the only element that has not hydrogen at the beginning is this one. So, these three in gray are acids, and this is a salt, sodium bisulfate. This is not a salt. Now, name to formula trap. Let's see. What is the question? Which formula matches ammonium sulfate? Okay, I go slowly, and I found ammonium. Okay, ammonium is okay. Ammonium is okay, ammonium is okay, and ammonium is okay. But what I am looking for sulfate. Sulfate is SO4 -2. Then which one is the correct compound? The correct compound is this one. Sorry. It's not this one. Why? Because it's ammonia. Ammonia is a polyatomic ion, is NH4 +1. As you have here a 2, then this 2 comes down, and then into parentheses you use 2 of this. Then the correct answer is ammonia sulfate. Well, here you have 2 more questions. I will stop the video here. You can read and you can see the correct answer. Okay? Well, I hope that you understand naming compounds or writing the name from the formula. Remember that depends on one thing. If you have a metal with a non-metal, it is an ionic compound and can be type 1 or type 2. Type 1, only one oxidation number. Type 2, more than one. And we also studied the compounds covalent that are made of two non-metals. In this case, we have to use prefixes to indicate the number of atoms of each element. Okay? And the last question is, which statement is always true? Prefixes indicate ionic charge? No. Roman numerals indicate atom count? No. Compound names reflect composition? No. Acid always contain oxygen? Well, the answer is this. C is the answer. This is the correct answer because compounds names reflect the composition. That's true. This is true. Well, that's all for this lecture. And if you have any question, please don't hesitate. Ask me and I will help you at any time. See you in the next lecture.